Hello, Richard here, and welcome to part 4 of the series on fixing the reverse gear noise on the mini lathe. Now, if you've been following along so far, you'll see we've tried a few different things to fix the problem, and we got pretty close in part 3. One of the things we did was to rebore this part here, because what we need to do is drill some holes in the back of the gearbox, and to do that I've made up a drilling jig which didn't fit in here because this hole wasn't smooth. So we've rebored this, we've got a drilling jig that can go in, and we're in a position now where we can actually drill some holes in the back of the gearbox, which is going to take a new one of these. This is the little plunger. We're going to make a new one of these, and that then is going to fit into here, the new one will, and that will then locate into the holes we're about to drill into the gearbox. So let's get on and drill that gearbox. Okay, so if you remember at the end of part 2, we had been boring out the lever housing for the detent for the gearbox, and we remachined the bore in here. What I'll do, I'm just going to get you over onto the bore scope for a minute, and I can give you a closer look inside to see how we did with that. So let's just do that. As you can see, it's a lot better than it was. The step has gone inside, and the finish is just overall better. I mean, it's not a perfect finish in there. If I wanted to get that better, I'd actually have to get a reamer and ream it out to get a really smooth finish, but it's not a critical part anyway. It just needs to fit better than it did. So as I say, I think it's cleaned up quite nicely in there. One problem we had that we said before is that because we made the drilling jig to be the old size before we bored it out, this is a little bit loose now. We've taken about 0.2, 0.3 mil out of the bore, so this is a little bit slack. It doesn't matter because, as I say, this is a disposable part and we'll recycle that in the future. So what we'll do is we're just going to shim this out with a bit of brass shim just to centralize it, and then we can fit this onto the gearbox, put it in position, then we can actually start to drill some holes in the gearbox. We've got some little strips of brass shim that I've cut here. Get these just to slip behind the drilling jig there. And we'll see if we can get sort of 3 in there equidistant, and hopefully that will center this up well enough and stop it from wobbling around. That's all we need to do, is just to stop it from wobbling as we drill. So let's see if we can fit that in there. See if we can get a third one in. That'll be the test, but hopefully we can get another one in there, and then we can just push that in a bit, and that should be good enough. So what that gives us is basically a 5 mil bore, concentric with the bore that we made. Then we can get a 5 mil drill, and that can just be guided through here while we drill out the holes, and it'll hold the drill steady. So the next job is going to be to get this clamped onto the gearbox. We'll clamp it in place, and then we can start to drill some holes. I'm just going to be using a normal cordless drill for this, and as you can see, I've got the clamp actually in the vise, so the clamp is clamping the work. This can't move anywhere, and it's in the vise. The drilling jig's in place, so let's get the drill in there, and then we'll see if we can cut a hole. All right, it went through. The brass shims have gone for a bit of a burden, but hopefully they held it in place long enough just to get it lined up. So let's see what we've got. All right, well, we got a hole through there. That's the first hole. So looks like we're on our way at last. So all I need to do now is get this repositioned for the next 2 holes, and we'll get those drilled out as well. Well, that's the holes all drilled, and as you can see here, we've got the forward gear position here, we've got the reverse gear position here, and you can see just how close the neutral position was as it's actually broken into the other hole, and the drill jig has helped, because if we tried to drill that without a jig, that drill would have just skated off into that hole and would have been a disaster. So pretty happy with that. Now the this hole here, the neutral position hole, that dropped down slightly, so maybe the drill jig moved. To be honest, the little brass shims didn't really work very well. They just kind of moved out of the way. I guess I could have seen that coming if I'd have thought about it a bit more, but so maybe that was it. Maybe we had a little bit of play. So I don't think it'll affect it. I think everything will sort of slot into line with that. Actually, as well, you can see here, there's a little groove here, and you can see that's where the detent handle, you can see where the point of this has basically scored a line through there. And I haven't even used the lathe all that much, and it's done that. So it's probably a good time to replace that from being a point to actually being a shaft that will fit into these holes. So we can get this fitted back onto the lathe now because we're done with this little bit. And then it's time to make a new one of these. Okay, so we've got the gearbox drilled out now. We've got holes for the new plunger to go into. And now we need to make ourselves a new plunger. So as usual, what we'll do is we'll have a look at the drawing, and we'll have a little review as to what we had originally. This is the original drawing that we did a while back, and a few things have changed since then. Since then, I've had to bore out this housing here. So this is a different size than it was. So some of these dimensions are going to change. Now, first thing we're going to do is look at this shaft here. Originally, this was 6.35 millimeter diameter, and the hole is 7. So as you can see with that, if I put that in here, there's a lot of play in that. I don't know how well you can see that. So if we can tighten this up a little bit, then that's going to help hold this thing more true in the in use. So what I'm going to do, I'm going to change this from 6.35. I'm going to make this diameter here. I'm just going to sketch this on here. So let's do, say, let's change that to diameter 7 millimeter is the hole. So let's go 6.95 for that one. Make that a nice close fit. That will mean we have a little shoulder on here, but that's okay. We'll just we might even put a little undercut in this part here, just to make it easier to thread. And I'll be tapping that with a, or tapping it, I'll be using a die. We'll cut that with a die, that thread. So maybe put a little undercut on there just to sort of tidy things up a little bit. For the other end, for the pointy end, we need to work out what we want to do for this diameter, because this is now a slightly bigger diameter than it was. So let's just measure that as best we can. It's a bit tricky to get at because I can only get at it from one angle, so it's a bit limited on how I can measure. If I measure here, I'm getting sort of 10.65, 10.75, going a bit further, 10.65. So that's looking to me like sort of 10.65 in that bore now. So let's just change that. So that's now 10.65. So on here now, this, I originally had this, the original was a 9.84. So this is going to be the new end that we make. And I'm going to make this diameter here. If I can draw, let's make that 10.6. We'll call that, say, 10.62, I think. That's going to put it sort of 0.03 of a millimeter undersize on this bit, which should be a fairly close fit, a lot closer than it was anyway. So I think that works out at about sort of just under 2 thou, 1.5 thou maybe in American measurements, and 0.03 of a millimeter, 30 microns in metric. So I think we'll shoot for that. 10.62 diameter on there. Now, according to this drawing we did a while ago, the end here, I was going to make 3 millimeters. Let's just check what thickness we've got on the casing. So that is, in fact, near as damn it 3 millimeters. So that's good. And the end I had as 1 millimeter with a slight radius on it, which means we've got sort of that much sticking out. I'm going to up that sticky outy bit. I'm going to up that to 2 millimeters, because what I want to do, I'm thinking about it a little bit. So on this end here, which will be the new end of this, I want that to be a bigger radius, because I want it to lead into the hole more easily. Well, as the plunger's on here, as we slide this over the hole, if I've got a bigger radius, it's going to just help it sort of locate and get home more easily. So we'll change that to 2mm for that dimension there. I think I'll be happier at that. Okay, now the other thing to check is going to be the size of the holes in here. We drilled those to 5mm with a drill, which isn't always the most sort of accurate way of doing things, but we'll just check what hole size we've got here if we can. So there you can see we've got 5.01, which is good on that. 5.04, and then on this hole 4.99. So we're looking good for 5mm. If I make this 5mm, that should be a good fit. But I can turn the end down to I can turn this down. Well, when we make one of these, I can turn this down to 5mm, and we can just test it in place. And I can always like fine tune that so it's a nice close fit. Certainly going to be better than it was when this was literally just locating into a center punch mark on either side. Right, so the next thing to consider really in doing anything like this is to sort of have a bit of a game plan as to how you're going to approach it. And when you're turning something, really, you've got sort of two choices. You either do that end first or you do that end first. So what we're going to do, I've got some 12mm mild steel bar, which we're going to make it out of, which means we don't have too much to come down on here. So this is close to that diameter. What I'm going to do is I'm going to make this end first, because what that means is I can hold a rough stock in the chuck, and then we can turn this down and we can get this pretty much down to diameter and get the thread on there, get this end finished. And then what we can do is we can basically part it off. So we'll part it off at the desired length. Then we can flip it around, hold this in the chuck, and then we'll machine this end. The reason is that when I grip this in the chuck might mar this shaft up a little bit, but it's not really going to matter because this isn't really the crucial sliding part, this bit. What I don't want to do is to make this end first, where I want this to be a really nice fit, and then hold that in the chuck, and then do things like sort of, well, cutting a thread's going to potentially might cause it to slip in the chuck and mar the finish. So we'll do it that way around. We'll do this end first, and then we'll flip it round, and then we'll machine this end. And that should be job done. So to the lathe. All right, the first thing we need to do is to face off the end as usual. That's usually the first thing we would look at doing. And what I've got here is I've got about 55mm sticking out of the chuck, because we need to actually turn this down to be 50mm long. So that gives me a bit of space to face the end off and a little bit of spare, so I don't sort of hit the jaws at the end. So let's face that off. Now, I will say as well that a few people have commented on the videos to say that the lathe is really noisy, and yes, it is noisy. It's a cheap lathe and it's quite noisy, but I will say that the noise on the video is far worse than it is in real life. So it sounds much worse on video than it actually is. Having said that, in a future video, we'll do some work on seeing if we can quieten things down. So I'll try and make it as quiet as I can for you, so it doesn't sort of blow your speakers. But anyway, I thought I'd mention that. So let's face this off and see where we are. Okay, how did we do? There's a little nick just out at the end there. That doesn't matter, we're going to be turning that down below that, so that's okay, that'll do. All right, so next thing we'll do is we're going to mark where we need to cut to. So this ruler will be fine for that. So what I'll do, I'll just measure in 50mm from the end. That's good enough. And we'll put a bit of black Sharpie on there and score a line, and that'll show us how far we need to come in. Okay, so we now need to take this down to, what did we say? We said 6.95 millimeters diameter for 50 millimeters long. And incidentally with this, because this is part of the gearbox, I can't do any automatic feeding. The lead screw doesn't have any feed at the moment, so it's all going to be manually fed. And to be honest, it's not a huge amount of metal to take off, so I thought I'd just manually feed it, and rather than sort of having to keep rebuilding the gearbox and take the gearbox apart every time, that would be a bit of a pain. So let's crack on and hand feed this to take this down from 12 millimeters to just under 7 millimeters. Okay, let's see where we are roughly on that. So 8.7 millimeters. So we've got about 1.7 millimeters to come off. So we're just sort of hogging it off at the moment. It's all pretty rough, and we'll refine it in a minute when we get a bit closer. Okay, that's going to be quite hot there. Yeah, you can see the smoke coming off my fingers as I touched it. So that's quite warm. That's one of the beauties of the carbide tools, to be honest. You can run them quite hot with no coolant, and they're really good for taking lots of material off. So let's just have a look at that. And we got 8.0 something there. So let's have a look. 8.04. I don't know how well you can see that. Let's try and get that on there for you. So 8.04. So we want to take off just over 1 millimeter. All right, so now we need to start being a little bit more careful, and we need to start measuring on the dial here. Now this is calibrated as each division is 1/1000th of an inch, 1 thou, as we'd say here in England, and that equates to 0.025 millimeters per division. But because that's how much it moves, it actually takes double that off the diameter. So each of these little divisions here takes off 0.05 millimeters. So in other words, 10 from 20 to 30 would take off 0.5 millimeter. And we want to take off just over 1 millimeter. So we're going to want to take off 1 millimeter being 40 thou, 40 divisions. I'm still not fully used to this dial. When you get a bit more familiar with a lathe, you kind of tend to just have a feel for what everything means. So I have to think a bit about this before I use it. So basically what we're saying is we need to come down about 1 millimeter. So I think what we'll do is we'll work towards going from we're on 25 there. Unfortunately, these aren't very easy to sort of re-zero because you've got to undo a grub screw and twiddle it. It's a pain. Maybe that can be a future upgrade to make these more user-friendly. But we'll take off 10 divisions, which should be 0.5 millimeter, and then we'll remeasure it. We should be about 7.5, and then we can go from there. So I'm not going to take the whole lot, the whole 0.5 millimeter. So I'm just going to creep up and say, let's just go 1, 2, 3, 4. We want to get to 35. So we'll take that off. And when we get to 35, we'll measure again. Squealing quite well there, probably because I've got so much sticking out with no centre on the other end, but let's see where we are now. So we are at 7.6. So 7.6, 7.69, I would say on there. So again, we'll take off another 0.5 millimetre, see where we are. So that's another 10 divisions on here. So 7.1 something, 7.1, 7.1 exactly, to be honest. I think that's 7.1 dead there. Let's just check with the calipers. Bit harder for you to see the reading there, but 7.07. So we're about 7.1, so we're almost there. Okay, so what we could do is we could actually try this part and see if it'll go on. Goes on some of the way. So we're very nearly there now. So we want to take off, if we said it was 7.1, we could try and take off 0.1, which then I've got to do my maths again here. So 10 divisions is half. So for 0.1, we would want 2 divisions, which would be 0.1. Yeah, that sounds right. Okay, so let's just do that. We'll take a tiny bit off. Now we'll measure that and then we'll see how it looks like it's going to fit. So 7.0 there, 7.0, where are we? 7.01 I would make that. We'll see how that looks like it's going to fit. Yeah, still a little bit cozy on there. 7.01. We wanted to bring that to 6.95. So we want to take off 0.1, just a tiny little bit now. Must admit, not a great finish on that. Feels smoother than it looks though, I'll give it that. It actually feels quite a good finish. It doesn't look very nice. Maybe I need to change out the tool. The carbide cutter might be a little bit blunt, but there's not a time to do that on the final cut. So we'll just take it very gently, take a little skim off and see if that does the job. Okay, where does that take us to? That takes us to, just under 7 mil. How much just under are we? So we'll look 7.9, 7.95. Sorry, 6.95. Yeah, 6.95. I've been giving you completely wrong numbers there. Right, 6.95, which is exactly what we were shooting for. So in theory, this ought to fit. There we go. Oh, it's a little bit tight at that end, but it's never going to get down that far anyway. So there must be a slight bit of taper on the lathe, but that's definitely a better fit than it was than the old one. If we look at the old one in there. So the old one was like that, and the new one is like that, which is good. We don't want this to be too tight. We don't want it to bind anyway, so that's good. So next thing to do is to take this down 6 millimeters for, let's look at the drawing, 10.5 deep, and then we can cut a thread on there. And what I'll probably do is take it 10.5 and we'll just put a little shoulder in there for the thread, probably on that. The shoulder, undercut is probably the word I'm looking for. So let's take that down and we'll mark it up and turn that down to M6 OD. Okay, that looks good enough. We'll make a little mark. Okay, so we need to take that down. Need to take a millimeter off that because that's basically it's 7 millimeters now. So we take that down by a millimeter. There we go. That's 5.9, 5.96. Okay, so now we can cut a thread on there. What I'm going to do, we said about putting a little undercut on here for the thread. I'll probably do that. We'll just get the parting tool. We'll put a little undercut on there. All right, so we'll get some lube on that as well, and I'm just going to eyeball this up to get it kind of roughly in the right place. Bit of cutting fluid on there. Dial the speed down as well for this, and then we'll just give it a little nick just to undercut the thread slightly on that. Okay, that'll probably do. I don't want to take it too far. There's so much sticking out of the chuck that it's likely just to sort of bind and hop out of the way. And then we're going to need a little bit of a lead in for the thread to go on there. So for that, I'm just going to use a file, and we'll file that on because that'll be just as easy. Okay, and then we'll, so there's a little burr on there as well. Actually, I'm just going to knock that off with a file while I'm at it. Okay, that's better. So we'll get a die, M6 die, and we'll put a thread on that. Okay, so I've got a M6 die here. It's all set up, ready to go. So what we'll do, let's move the old carriage out of the way a little bit, because I'm going to need to sort of get up there, and we'll bring the tailstock in. Let's see how far I can move that out of the way. That might still be in the way there. A little bit limited for space here, how we do things. So yeah, I'm going to need to move that back a little bit more. So bear with me while I just kind of work out what I'm doing here. Hopefully this is going to extend far enough to be able to support the die to some degree. Probably not, looking at that. Okay, let's have a rethink. Let's move, see if I can move this over this way more. Because we're not actually powering the lathe at this stage. So how's that going to work? That'll do it. What I'm looking to do is basically I want to use the tailstock to square up the die as I start the cut. That's all. Ideally you'd use like a special tool for this that would sort of be like a spring-loaded die stock holder, but I don't have one of those, so we improvise is what we do. So let's see if we can get that somewhat in the right place, lock that off, and then what I can do is put a little bit of pressure on here just to hold things square, get a little bit of a cutting fluid on there, and then we can hopefully start to cut a thread. And I'm just feeding the tailstock feed in gently as we go, just to get things started off and keep it square. Now I'm going to just back off a little bit, break the chips if there are any. Okay, it hasn't started too far yet, so we can just continue with that for a bit. Bring this back in, we can take that a bit further actually as we get it going. And then what you want to do about every sort of quarter turn, just break the chips off, break the swarf, and usually you feel it go like that. I can just feel the swarf go. And once it's started, you don't really need the tailstock to keep it square because it's going to be threading as it goes then. Give it a turn, break the swarf, a little bit more cutting oil in there. Rinse and repeat, really, that's it. So we're not cutting too much of a thread in one go because we don't want to sort of spin the work in the chuck, if we can help it. So we just gradually sort of creep up. Of course, the other thing you can do if you've actually got power feed is you can screw cut the thread on there. Just actually do it with a power feed and a threading tool. And one way you can do that as well is you can actually sort of rough out the thread with a power feed and then just run a die over it just to tidy it up. Now this is starting to tighten up a little bit, so I'm going to back it off, Get a bit more cutting fluid on there. It's amazing really even how like an M6 die takes a fair bit of cutting. And I've got the die expanded fully out. This middle screw is fully in, which expands the die out. So it should be cutting the largest thread it can at the moment. And it's still a little bit tight on there. But we'll take our time, no rush. Let's move this out of the way actually. That's cramping my style now, so let's move that out of the way. I'll probably move the carriage out of the way as well, actually let the dog see the rabbit as it were. And let's move that out of the way, and then I can probably get on it a bit better. That's better. I can actually get my hands on it now. We're getting there with it, not far to go. Just back it off. Bit more oil. And that's about it. Job done. Now, I mean, you could be tempted with this to sort of put the lathe in reverse and power it up and power feed this off, as it were. But I always try and avoid getting my hands in the lathe. I don't, this isn't a wood lathe. It's not really designed to have hands touching rotating things. So I'd rather take a few minutes, do it by hand, not put myself in any kind of danger. There's a little bit of a burr on there, so we'll need to tidy that up. We can just run a file over that just to clean the burrs off of that. But that's looking pretty good. So let's just clean the junk off, and now we can put some power on and just clean that burr off there a little bit. And again, with things like this, don't ever be tempted to sort of touch it to feel how smooth it is. That's not what you do on metal lathes. Save that for woodworking lathes. Keep your hands out of it. That's nice. That's no burrs on there. Okay, so let's give it a little test and see if the little caparoni will fit on there. Hopefully it will, if we've got everything done correctly. There we go. Excellent. What I will do, again, I'm just going to run a file on the end there. It's just easier than setting up a specific lathe tool to do that. I just want to deburr the end slightly. So we'll just round that off. All right, so next thing to do is to move it out a bit further so we can then part it off, and then we can flip it round and get ready to do the other end. All right, so I need to part this at 20 millimeters because that's sort of how much more we need. So I just need to work out how much I need to extend. I want to keep this as tight to the chuck as possible because parting off puts a lot of force on things. So that'll probably do. Just tighten it up there. Make sure this is good and tight. Okay, we got the parting tool in there, so let's get that fitted. And I'm just going to square the parting tool up against the jaw to make sure it's sort of nice and perpendicular. Okay, that looks good. And I need to part off at 20 millimeters in. So we'll just measure that with a ruler. That'll be good enough for what we're doing here. It doesn't have to be hyper accurate. And again, I'm going to lock the carriage to the lead screw, because there's a tendency for it to want to move sideways sometimes. So we'll lock that in. The lead screw's not, you know, there's no gearbox in it at the moment, so it's not going to go anywhere. And yeah, we'll see if we can get that parted off. Oh, just jammed the lathe up there. So let's have a look at what happened. Did I actually crash the tool, or was it just a bit too much for it? I think it was just a bit much. It must have dug in. Let's try again. A little bit of oil in there. There we go. So yeah, when I just locked the lathe up there, and that's one of the beauties in a way of having a lathe where the motor power is quite well matched to the lathe. So when something goes wrong, it just stops and you can just sort of back it out. I was just hogging a bit too much metal off then and it locked up. If the motor was way overpowered for the lathe, you'd probably have broken something at that point. But anyway, let's see if we can find the part. And there we go. So that's the first half done, the first bit. So we've basically sort of mimicked it thus far. And this shaft now is about 0.6 mil fatter, so it's going to wobble less. So now we need to just turn it around and we can then work on this end and get this shaped up to replace this. And this is going to be a much sort of finer tolerance on this bit. This needs to fit the hole quite nicely, but let's get on and do that. Okay, so I've turned this round in the chuck now, and we'll just face off that pip from the end, and then we'll take this diameter down to, refers to drawing 10.62 millimeters diameter. Okay, let's see how we're doing. 11.6, 11.65, I would make that. So we've basically got exactly 1 millimeter to come off, well, a tiny bit over. So now we start again thinking about what we're doing here. So we want to go basically 20 divisions on here should give us that 1 millimeter, if I remember rightly. But we'll take it up to 10. Well, we'll take off 10 divisions. That should take us down to about 11.5, and then we can, 11 millimeters, and then we can go down from there. Okay, we should be about 10.5, 10.6 maybe. Sorry, 11.5. Actually, we're a bit lower than that. 11.1. What am I talking about? We should be at more like 11.1, exactly. We started at about 11.6 and we've come down half a mil. So 11.1, 11.13. So we want to take off 11.13. So we want to take off exactly 0.5 of a mil. So again, that's another 10 divisions. So what I'm going to do is probably take off, say, 8 divisions, and then we'll creep up on it from there because I want this to be quite exact. So we got 10.7, 10.73, I would make that. So we've got 0.1 of a mil to come off, which is, yeah, about probably 2 divisions. So we're sort of smack on where we want to be now. So we'll really creep up on it from here. So now we're under 10.7, so we're on 10.6, 10.66. And we want to be on 10.62. So 10.63, I would make that. So that's really close to where we want to be with it. Now the problem is I can't actually test this on here without taking this off, and I don't really want to do that, because if I do, I probably won't get it back in being square. So let's just have a little think about that. I'm going to double check on my calipers, just a sanity check. Yeah, I'm getting 10.61 on there. You can see that. 10.61 on the calipers. .63-ish. .62. I'm going to go with that. That's very close to where I want to be. And we'll carry on and we'll just machine the end on it. And then when we fit it, if it's too tight, I think what we'll do is we'll just pop it back in the chuck and just polish it with a bit of fine abrasive paper, some 240 grit paper, to just sort of fine tune it if we need to. All right, so the next thing we need to do is to basically turn down the end, and that's going to be 5mm in. So let's make a mark. And again, this doesn't have to be mega exact. I'll take a little over 5mm, I think, on that. So we'll make a little mark. And that end bit, now we'll turn that down to 5mm, so there's a fair bit to take off that. There we go, that's just under 5 there. So we got 4.95 on that. So I'd call that done, I think. And what I'm going to do, I'm just going to sort of take the tool slowly across on a spring pass, and then I'll draw it back out along the face just to try and square that up. Okay, right, that's good. Next thing to do is I'm just going to chamfer the end of that, and then what we'll do is we'll just file that to a dome, clear the burrs off, and then we'll see if it all actually fits. That'd be something, wouldn't it, if it all actually fitted first time? You never know. All right. All right, so I've got a threading tool in there. I'm just going to see if I can knock the end off that corner. Okay, that's pretty good. And then while I'm at it, I'm just going to deburr that end. I might see if I can sneak up on here and just take the burr off that side as well. Yeah, I can sneak in with that. That'll be fine. Let's just tighten that up. Make sure we got clearance. Okay, so once again, we'll reach for the file and we'll just see if we can put a little round on the end of that. Right, and there we go. That should be it. So, do you think we dare try it out? Let's give it a go. Take it out of the chuck. And yeah, you can see we didn't really scratch up that surface too badly. There's no sort of real scores in the shaft there, despite holding it in the chuck. Right, well, moment of truth then. Let's see if I can get you so you can see that. Will it fit? Oh, very nearly. It's a bit tight in there. To be honest, let's try it the other way around, just see if it will go in nose first. That's really close, really, really close. So yeah, you can see that's really, really wants to go in there, but it's just not quite there. So just double check the other end. Okay, we'll take a fraction off. So I might be able to just polish that. So we'll try that first, because then I don't have to actually center this in the chuck. So we'll just get that roughly in the chuck like that. It's not going to be very tight. All right, so I got some 240 grit wet and dry paper. We'll just wrap that around a file, and then we'll give that a little bit of a polish. See if that'll be enough just to take it down. Certainly gives a nice finish doing that, bit of polishing. Let's have a look. It's very close. It's that close. Look, it actually goes in now almost. So it's very close on there. And that end goes in. So it's possibly that it's binding a bit on the hole on the back as well. But it's certainly almost there. you know, a little bit of manipulation and bedding in, and that's going to fit really quite well. Let's have a look, see if we can see any kind of marks on there. So yeah, it just needs a little bit of teasing into place, I think. What I'm going to do as well while we're here is let's just check the this end piece as well, see if that'll actually fit in the holes that we made. Oh, that's great. That goes in really nicely in those. That fits really well. That's good. Okay, so that's that out of the way. Let's just take a little bit more off of this. It's getting ever closer every time. Something's just not quite going all the way with that though. But that's I mean, that's actually a really nice fit there. It's just not quite going. I don't want to force it either. I mean, I can probably sort of bully it through there a bit and it would be okay. Honing out that bore a little bit. I'll tell you what we'll do is let's assemble it with a spring and get the handle on it. Of course, the spring, I didn't take that into account either. The spring's quite tight on there now, so I didn't really think of that. Never mind. Let's pop that in. Obviously, it's a lot harder to assemble now it's accurate. I mean, it might be enough. This thing doesn't have to go in all the way, I suppose, does it? So, God, it's actually a bit of a job to get it to go now. Oh, okay, the spring's just binding up on there a little bit. So, let's see if we can get that over there a bit. To the point we can get a bit of a thread on. And see what happens, I suppose. Because with the handle on, well, that's probably about it. That's oh yeah, I think a bit of manipulation and a little bit of oil, that ought to bed in. There's basically no play in that now. Tiny, the play is actually in this. This is what's moving. This isn't moving at all when I do that, really. I don't know how well you can see that on the camera. So I think we'll just use that to sort of, I think we'll just run that in. I think we'll, through use, a bit of oil, I think that's good enough. All right, there you have it. That's the finished article. So all that remains now is to put the gearbox all back together, fit this, and hopefully we'll have a nice, quiet reverse gear on the lathe. You never know. Okay, so we've got the gearbox all back together, hopefully for the final time, and we've got a new detent plunger installed. Now, I must confess with this, if you remember that on the drawing, we said a while back that we were going to add an extra millimetre to the length of this. And you notice as well, I say like we, bearing in mind the first rule of engineering is always spread the responsibility for mistakes to other people. No, but seriously, I added a millimeter onto the length of the plunger sort of at the last minute, thinking I could do that to make the thing more curved. And yeah, it didn't work out very well because it basically clashed with one of the holes, the top hole. You wouldn't clear it very well. So I actually ended up having to take it out and cut that millimeter off and recurve the end of the detent. But anyway, that aside, it's all in there. And this is in the forward position. So if you look at what it was like before, you can see just how much play there was. If I move the chuck backwards and forwards, you could just see how much slop there was in the tumbler gear, and hence the gears were hitting. But if you look at it now, if I do the same thing now and I just manually turn it backwards and forwards, you can see there's almost no movement at all on that lever. It's really rock solid now. So that's really great. Also, what we've got now, which we didn't have, this is the forward feed position. So the lead screw will be in like normal forward mode. Now what we've got is we can actually put it into neutral. So if I, excuse my hand, hope that won't get in the way. We can now put it into neutral. So you can see now the gears are not meshing, and this is actually locked in neutral. Before, there was no neutral position. You just had to guess it. You have to have this in such a precise spot to get it in neutral. It was always really difficult to not have one of the gears kind of just touching and causing problems. And also we've got obviously the reverse feed position. So that works really nicely. That kind of slots and locks into place now. And it's really positive, and there's no movement. I can barely move that now. There's a tiny bit of play, but nothing to speak of. So what we'll do is just power it up, and you can sort of see it. Now, I will say that this lathe sounds a lot noisier on the microphone than it sounds in real life, and I know a few people have commented on that in previous videos. This will probably sound really noisy on the video and horrible. Bear in mind, it's about sort of 5 times better in real life. But there's a great improvement in the smoothness of this. So let me just show you what I mean. If we fire it up in forwards. Now I'll just switch the lathe to reverse, electrically switch it to reverse. And then what I'll do, I'll put it back into forward there and reverse feed. And then we'll put it in reverse we'll reverse the motor and try that again. And that's running absolutely sweet as a nut there now. As sweet as one of these things will ever run, to be honest. They're not the quietest of things. But anyway, yeah, so I'm really happy with that. That's absolutely nailed the problem there, albeit a little bit more elaborate than we thought. But yeah, worked out really well in the end. So there we go. I've now got a fully working lathe. Well, I'll say fully working, mostly working. Certainly one that I can do screw cutting with, and it's got a really nice sort of forward and reverse gear action now. And I really didn't expect it to take this long to fix it. I thought that in part one of the video, we'd have a look at it, we'd find a little bit of metal needed filing off, or a bit needed adjusting or tightening up somewhere. Wasn't expecting to have to make 2 brass bushes and make a new detent plunger and make all kinds of tools as well to get us along. But you know, it's been interesting. And if you followed it along all the way up until now, then I admire your stamina, because this has been quite an epic fix. I've got plenty more planned for this. This isn't the end of the mods to the mini lathe. We've got a few more things to do, quite a few more things to do. So I'll be sharing those with you as well as time goes on. And as usual, what I'd like to do is sort of show you the thought process, you know, not just show you like a perfect sort of Hollywood style, here's the perfect way to fix it. I like to show you all the things that go wrong as much as all the things that go right, you know, so hopefully you enjoy watching that as well. Anyway, thank you for following along with the series. I hope you found it interesting. I hope it's useful to you if you've got a similar mini lathe and you've got the same sort of problem. And until next time, thanks for watching.